everyone, I am KK Lamula, a BSEd Mathematics student, and welcome to my YouTube channel. For today's video, we will discuss the derivation of two trigonometric formulas from Pythagorean identity and how we can apply it to a real-world problem application. So to start, let me tell you why learning trigonometry is crucial through mathematics, engineering, and other courses.
Trigonometry serves as a foundation for understanding concepts such as limits, derivatives, and integrals, which are essential for studying calculus and other advanced math topics. Also, it is important because it helps us understand how the world works, calculate heights and distances, analyze periodic phenomena, calculate forces and motion, solve problems in engineering, and prepare for advanced math courses. In deriving Pythagorean identity, there are many ways to derive it, but I'll use the more sufficient and easiest way. First, let us draw a right triangle with theta here, side A, B, and C. In a unit circle, this side A here is the opposite because it is the opposite to theta. B as the adjacent and C as the hypotenuse. So in a Pythagorean theorem, we have the formula a squared plus b squared is equals to c squared. Let us remember that sine theta is equals to opposite over the hypotenuse, or a over c. And cosine is equals to adjacent over hypotenuse, or b over c. So in this equation, we have to divide this in c squared and rewrite each expression. So this becomes a squared over c squared plus b squared over c squared equals c squared over c squared. So this becomes a over c, open and close parenthesis, squared plus b over c, open and close parenthesis, squared equals c squared over c squared is equals to 1. Since sine theta is equals to a over c, we're going to substitute sine theta in our equation. Squared plus, we're going also to substitute the cosine theta, which is the b over c. This become cosine theta and squared. We can rewrite sine theta squared plus cosine theta squared equals 1 into sine squared theta plus cosine squared theta equals 1. So to find the remaining Pythagorean identities, we can use this equation to find them by dividing sine squared theta or cosine squared theta to our equation. First, we're going to divide cosine squared theta, sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta equals 1 over cosine squared theta. So, in quotient identity, sine squared theta over cosine squared theta is tangent squared theta plus cosine squared theta over cosine squared theta is equals to 1 equals 1 over cosine squared theta is a reciprocal of secant squared theta. So since we're already done dividing the cosine squared theta to our equation, we're now going to have the sine squared theta. So sine squared theta over sine squared theta plus cosine squared theta over sine squared theta equals 1 over sine squared theta. Sine squared theta over sine squared theta is equals to 1 plus cosine squared theta over sine squared theta is cotangent squared theta equals cosecant squared theta. So these three are the Pythagorean identities, but we can also have another equation by using subtraction. We have an example here. So suppose you have a triangular ruler with sine theta equals 15 over 25. Find the remaining side and identify the cosine theta with theta is greater than 0 degrees and less than 90 degrees. Let us draw a right triangle with the given sine theta equals 15 over 25. So to find the remaining side in the cosine theta, we have to use the Pythagorean identity, which is the sine squared theta plus cosine squared theta equals 1. Substitute the sine theta, 15 over 25 squared, plus cosine squared theta equals 1. 15 squared is 225 and 25 squared is equals to 625 plus cosine squared theta equals, so 1 will become 625 over 625. So cosine squared theta is equals to 625 over 625 minus 225 over 625. So 625 minus 225 is equals to 400 over 625. So getting the square root, so So cosine squared theta will become cos theta equals 20 over 25. Since cosine theta 20 over 25 can be reduced, it will become cosine theta equals positive 4 over 5 since cosine is positive in quadrant 1.